Check.
Yep, we're good.
Okay. Thank you everyone for coming to our talk on bridging Bitcoin, sidechains, and light clients. The focus today is how to achieve robust light client security for scaling Bitcoin. I'm your moderator, Nathan, with Rollux. We have Jagdeep Sidhu, founder of Rollux, Dominic Hars, co-founder and CTO of Building on Bitcoin, Kevin He, co-founder with BitLayer, and Tuche Smith, marketing lead at Sidechain. Thank you for coming. So let's get into it. First question, starting one by one. Please explain the pros and cons of building on Bitcoin directly versus utilizing light clients and the paths your projects have taken to address the trade-offs of your tech stack. How do you justify them and how do you minimize them?
I haven't read the question, so I'm just gonna wing it here. Okay, so our view on a lot of this is Bitcoin is this 4-layer stack within Syscoin from 2014. We've been building on this for 10 years. Bitcoin is the operating system host. It's the secure, decentralized layer. It's got the Lindy effect. It's it's stable and decentralized and it's deterministic. The second layer would be your operating system, and our view is the EVM has got the moat on basically like if you're going to do smart contracts or Turing complete computing. Then the third layer is ZK, so we think there's something, I coined the term decentralized cost model, and that means the computing is going to be based on the cost of your CPU directly, not the opcodes in a blockchain, so that the consensus level, in the Ethereum you have costs on how much it costs for a certain opcode like block hash, versus in Bitcoin you have opcode costs as well. And the decentralized cost model means if you're doing ZK on any computer, the base level cost of that is some level of electricity that you've used to compute a proof of any sort of logic, right? So that's the decentralized cost model, and only ZK can really get that for us. And then the application layer is the fourth layer. So those are this is our vision on the fourth thesis, right? So where Bitcoin versus layer twos. So as a host, your job is to be decentralized, secure, and minimize the MEV attacks. And I spoke to Matt Corallo quite a bit, OG Bitcoiner, just recently, and he's concerned that the Bitcoin layer 2 is going to create a lot of MEV attacks, rolling back Bitcoin for bounties. And when you have those sorts of attacks with layer 2s especially, setting up these bounties, say 10,000 Bitcoin tomorrow moved over into some decentralized bridge. Right now, like Merlin Chain, all these, they have tens of thousands of Bitcoins, but they're institutional bridges, so it's fine, right? Because institutions just controlling the multisig. But when those get around into becoming decentralized, that's when you have the attacks. Because you have 10,000 Bitcoin sitting there, it's going to cost you 2,000 Bitcoin to roll Bitcoin back a couple hundred blocks, just for sake of conversation, say it's 2,000 Bitcoins cost to do that. Then that's going to happen. There's an equilibrium where I make 8,000 Bitcoin as profit. The numbers might be different. So layer 2s set up this bounty system, this sitting duck that it has not been analyzed, and that's where light client security starts to matter. Whereas scaling on Bitcoin, a lot of those issues don't happen because you can introspect what's happening in Bitcoin itself. So if something happens in that system, there's no sitting duck. It's just the Bitcoin system can validate it's true or not. And a sidechain, it can't. So these are the sort of things you got to think about. The problem with doing it all on Bitcoin is it can't scale. You only have 1 megabyte of block space available. So if you're trying to do, like with Opcat, you're trying to do a whole ZK rollup on Bitcoin, you end up having this big issue of scale. And that's what sidechains can do. So I see a path for both. And both are important. And both solve different problems. And both need to solve problems in the most secure way possible without sacrificing the story of what Bitcoin truly represents.
Cool. Sorry for being late, first of all. We with Bob, we have kind of our own thinking obviously around that, and I think it's great to see so many different sidechain and L2 approaches right now that explore different parts of the design space, because there's no one true way to kind of scale Bitcoin, and I think we'll figure out, who's gonna end up being like the winner in that game, and maybe it might actually be multiple different L2s because there's different trade-offs that you can make. And I want to kind of answer the question in a way that it is from a perspective from project building on Bitcoin versus like Sidechain's L2s. If you're a builder and you're looking at doing anything on Bitcoin right now, you will be confronted with a lot of kind of complexity in dealing with the UTXO set, and especially if you want to do something, say, with runes or BRC20s, ordinals, you get this additional index of complexity as well. And if you ever, just for fun, try to do transaction estimations without using one of the existing libraries and figuring out, okay, for an ordinal, how much fees should I actually be spending that I don't overspend, you quickly realize that it's very complicated to build on Bitcoin right now. And I think one big thing where both sidechains and L2s, and we're kind of same opinion, like EVM is probably the one that works quite well. If you build on these right now, on an EVM, you have a lot of tooling that already makes it a lot easier for you as a project to deploy something. And I see it as a task for Bitcoin mass adoption to enable builders to quickly build products, try it out, figure out what works with end users, make it as easy as possible. And the job for L2s, like all of us, like trying to scale Bitcoin, our hard job is it to abstract away as much as possible of that complexity while retaining security and alignment with Bitcoin. And this is where I see essentially us all together kind of heading into a quite nice and interesting future, where with BigM, with potentially maybe ZK proofs that we can get on Bitcoin at some point, we will explore kind of that space together and be a net positive for basically every Bitcoin user. So yeah.
Sorry for the late. My opinion is clear, and I think the layer 1 should look for the asset issuing, asset protocol, and ZK proof, ZK verify. That's enough. No more needed. And the execution and the other things and the complicated or the sophisticated expression of the programs, let it be on layer 2 or layer 3. For me, it's clear, so clear. Yeah, thank you.
Thank you. I guess from our perspective, we will define building directly on Bitcoin. We'll be using Bitcoin as a DA layer and a settlement layer. Now we can by BigM, right? There are clear pros of using Bitcoin as a DA layer. You inherit Bitcoin's liveness, real resistance, censorship resistance. If you want, like us as Citria, on-chain finance secured by Bitcoin, and Bitcoin being the native asset of this finance, you use Bitcoin as a DA layer. However, like Jagdeep said, of course, it comes with certain costs, right? Bitcoin DA is expensive. I mean, at the end of the day, you get what you pay for. You pay for that security. However, that space needs to be utilized very efficiently. So at Citria, what we're trying to do to optimize usage of that space, we are inscribing state differences instead of full transactional data. And as more people use Citria, transaction fees split among those people, so you get low amount of fee, and you utilize block space very efficiently. However, to further scale, you need to go beyond that. And in our roadmap, we have evolution models, so you can have layer 2, layer 3s on Citria to further scale and get cheaper transactions and application-specific rollups on top of Citria. So the road ahead is exciting, but there are definitely cost issues with DA. And I'm really excited that public DevNet is coming soon, and I think for the first time we're going to see with Citria how Bitcoin works as a DA for the first time. So I'm really excited. Myself, I also want to see transaction fees, how much it can handle. It's going to be a nice experiment with our public DevNet.
Tucci. Second question. Some camps criticize abstracting away from Bitcoin in order to provide additional utility. I guess that's not you guys. But in general, I want to know how pro-abstraction teams would respond to criticisms like that, how you would criticize it or how you would defend it if you support abstraction, and why do you believe this is the most optimal solution?
Yeah, I guess like you said, also, I guess I'll go from Dominic's point that you definitely need to improve user experience and developer experience, and you can do that with your execution environment by choosing EVM compatible. There are a vast pool of developers out there knowing, Solidity, so you can improve that in your execution environment. You can also, by building a real, I guess, game solution, you can onboard new people to Bitcoin non-custodially with user experience. I guess I will kind of look from that perspective. But obviously, from our standpoint, we wouldn't want to forego Bitcoin security for that. So our design kind of established accordingly, right? But user experience and developer experience are extremely important and needs to be fixed, in my opinion. Just we wouldn't sacrifice Bitcoin security for that.
Yeah. For me, nothing can be perfect at the early stage. At the first version, everything should be changed according to the situation change and the time change. Even though some kind of Bible, some kind of constitutional, something like that, everything should be upgraded and modified or add more expression about something of the original version. So maybe this is the first point. And second, kind of fence of OPCats or something like that. But I do think we need to push this forward under the before we consider it is secure. This is very important. And for the next, I think so we think that even though we made the current situation for us, we are going to build ZK verifier and without OPCAT. This is how the BigM community and BigM projects are making the something like a breakthrough here. So to conclude, we think that things should be changed up time by time. Second, we don't wait for the OPCAT.
Right. I think everybody wants Bitcoin security, and the whole, I guess, discussion about chain abstraction. That's usually only because you're so limited on Bitcoin, right? That you can't really do anything that you really want to do. So now the question is, how do we, do DeFi? How do we get microloans in Bitcoin, implement stablecoins, all that jazz? And the way that we're approaching it at Bob is basically saying there's right now BigM isn't working in production yet, so we can't verify anything right on. We can't verify an L2. We can't really verify a sidechain in BigM yet. The one thing that works right now is opt-in via merge mining. So BigM miners can verify your sidechain, like Rootstock, for example, and in that way you get some Bitcoin security. So the way that we're approaching it is a roadmap. So right now, the way that Bob mainnet works is it's actually it's a hybrid rollup. So it settles to Ethereum, and we're adding merged mining so that the centralized sequencer trust is offset by having Bitcoin miners verify that and be part of that, verification set and having a profit out of verifying that rollup. And everybody, I think, wants here to have BitVM actually properly working, and I think that's the long-term vision, and that's how you get proper Bitcoin security. But it still comes with a lot of trade-offs, and there's vast amounts of research needed until we can get to that stage. And yeah, for us, kind of in the design space, we think that having kind of Ethereum consensus security and then Bitcoin merge mining security is pretty much very close to what we want to ideally have in terms of security model until BitVM works.
Yeah, we think even if you go down the road of UTXO scaling, you are going to end up at a dead end unless you have some sort of accounting model. This is again, our thesis was the EVM model is the standard for general purpose computing, right? Think about a DEX, an AMM DEX. There's shared accounts, and in the shared accounts you can send money in, take money out independently of who is who. And the UTXO model, you have to sign over the UTXO from the sender, and it has to track who the UTXO is inside that pool of money. Cardano, like Charles, has been working on EUTXO for forever academically, and they can't figure out how to do that sort of DEX, so they created other alternative DEXs that can solve that. There was a ZK rollup on Cardano that got kind of ran out of funds, and the foundation didn't cover it. It was surprising because it was really interesting, but they found that they needed to switch to an account-based model from the EUTXO to the EVM sort of solution to be able to do those things that people care about. So when you're talking about ZK is just going to solve everything, on Bitcoin, sure, I mean, it can solve the problem with checking the state. But if you're still dealing with UTXOs, you're going to have those same problems. You can't do what you need to do with standard true and complete smart contracts. The benefit you get from there is you get the introspection, especially with Opcat, you get the ability to check certain things. So the validation is actually happening on Bitcoin, which means you don't actually have a lot of the attacks that you have on the sidechains. But if you do want to do something, I'm not saying it's going to be a dead end, if you do want to do something more, like AMM DEXs or other smart city things that people are imagining in the future in these blockchains, then you're gonna have to look at something like an account-based model, which lends itself back into a sidechain like an L2. That's why I see both living. The other thing is you can't enshrine a DA on Bitcoin. It's not gonna happen. You can't enshrine a DA on a layer 2 either. So Citria can try to do a DA, but it's not gonna have the same level of security as Bitcoin, right? You have to have the light client security assumption to figure out what is the level of security of your DA if you're going to do a new bit or some other DA layer. So those are the other questions. If you're going to go move your Bitcoin as an IOU into a secondary system, then you have to ask the questions, okay, what is your light client security to know if SHTF moment happens, what are the chances that Bitcoin is gone in certain circumstances? So that's the focus of our research is do as much as you can on Bitcoin to get the utility, but also we know that the world is going to be thinking about account-based models and scaling through EVMs with sidechains related to Bitcoin. And if the world is looking at that, then what are the variables that matter? And what we found was the light client security are the variables that matter. And so we've spent a couple of years researching that to figure out how do we isolate those variables to make it as secure as possible.
So what recent innovations or methodologies do you find most promising for enhancing the security of Bitcoin layer 2s? And could you share some examples of how you think these might be applied in real world scenarios?
Yeah, I really like BitVM. I think being able to, like everyone was saying, being able to have general purpose computing is a real bonus. With Opcat, you're going to get introspection, and so you could do, I think Wei Kang Chun is working on a Stark-based prover that can generally prove anything. Obviously, you can't prove DA, but you can prove general purpose computing within the UTXO model. It would be really great to be able to do general purpose high security vaults or all these other things. And Andrew Polstra really came up with these ideas in 2021 when he did his Medium post on it. And he showed like 3 or 4 major use cases, but there's probably going to be hundreds of more. So BitVM takes it a step further and generalizes it, says that you can write any program you want and it will be secure through an optimistic assumption. But the problems with BitVM are that, okay, for BitVM 2, anyone can challenge that claim. If you are doing something like bridging or something else and someone puts their hand up and says, look, I think you're doing something wrong, I need to stop this from happening on Bitcoin, you have an optimistic fraud proof. And that optimistic fraud proof lets anyone be involved with the ZK proof. The problem with even in that solution is the operator list is still static. So Robin Linus was saying, why don't we have 1,000 operators, all institutions? and that's just the people that can move the Bitcoin out or do something that goes back to Bitcoin and says this I'm allowed to make this state change. For example, in a bridge, if people are using BitVM for a bridge and there's 1,000 operators, then only one out of those 1,000 are allowed to move that Bitcoin back out. It just assumes one honest party, right? But if 100 years later that 1,000 is no longer existing, then the Bitcoin might not be able to leave. So the decentralization aspect of that becomes critical. So some of the things we're solving for is doing something like an eigen AVS but Bitcoin behind it for the operator list. So the operator list can grow and shrink over time and have crypto economic incentives, and now also be slashable if someone's not doing something right. So those are the things we're thinking about is, okay, BitVM is great, but what are the challenges with it? How can we solve that through maybe crypto economics?
Yeah, those are great points. I kind of want to not go too deep into BitVM because I think everybody will mention BitVM as like the core enabler. If I want to pick one specific part, then it's probably the bridging part. I think one aspect that most people overlook when they think about, oh, we're now doing rollups and L2s on Bitcoin, is that probably the hardest thing to actually build is the bridge to that L2 or rollup, because you still need a bridge. And that's kind of a common misconception that I come across even in the Ethereum space, where people think that just because you have a rollup on Ethereum, it doesn't need a bridge. You still need a bridge. You still need to somehow, verify that assets that you get over and back from your L2 are correctly processed. And a kind of, I mentioned BigM again, that once we have BigM working, people need to think about how do we actually implement a light climb for our rollup or for the bridge that we want to verify. How do we actually reason about finality? Do we have such a thing as finality on an L2 with which we can say, oh, there was actually fraud in there, because if it's not yet finalized, you can't really do anything, and there's going to be so many trade-offs in the process. And one thing that I'm actually quite excited about talking about technology is actually a little bit the revival of this whole merge mining thing, because you could basically optimistically produce blocks on your L2 and then have finalization through miners. So let's say you get really good miner opt-in, like 80%, 90% of the Bitcoin miners merge mine your sidechain, your rollup. Then you can use that, for example, as a means of finality if enough work has accumulated, and then you could use that in your light client that you then implement in BitVM. And I think that's something that's pretty cool, and that's a bit underexplored right now, and I'm excited about that research.
Yeah, everybody talking about BigM. Actually, I'd like to talk something more about it. Actually, I think, firstly, if we talk about the BTC layer 2 security, first we need to define what is a BTC layer 2. This is very important. According to, actually, different people, different community have different ideas about what is real BTC layer 2. Let's just use Bitcoin magazine's some kind of definition. For example, using Bitcoin as a native token. Second, using Bitcoin as a settlement layer. I think that, and the third point, I think the second one is very important. Using Bitcoin as a settlement layer. Then we can define what is a settlement layer, how to define a settlement. So this is back to two standing points we start big layer projects. I think the first we need to respect and learn the latest advantage of Bitcoin technology, including DLC, BigVM, RGB, and etc. And second, we should learn the whole the technology and the knowledge during the Ethereum's layer 2's landing in the last few years. Because in the end, big Ethereum layer 2 just set a very good example for the whole industry, including the whole crypto industry. The people just reached a great consensus on what is real layer 2. That means that we need to settlement things on Bitcoin. Then we did to the I will talk about the technology I talk about DLC. DLC is a very good model to introduce a new model to build a bridge. People can have part of their control of their assets because it's a 2-to-2 multisig and introducing a Oracle, but Oracle itself has a trust issues, so we need to some kind of ways to make it decentralized. And the BigM actually we are the first projects that want to build on BigM paradigms, but actually we don't want to wait for them the official or progress, and we are now have contributed a few articles for them. And third is about the RGB things. I think RGB things just a new paradigms. We need more research on it. People are need more social consensus about it to reach a better popularity. Yeah, this is my conclusion about this topic.
I guess I'll take over from like client perspective. I really like what we do with Sovereign Labs. So basically using inclusion and completeness proofs for like clients. So this allows us to actually verify Satria in one single success proof. You know, like client has to know that each proof in the series is dependent on the validity of the previous one. So in inclusion completeness proofs, we have entire Satria state in one single proof so that you can easily verify, which is obviously crucial for BigM. Have to use the right keyword. I think that's, I find, ZK proofs are awesome. And recursive ones, I think, even more awesome. So that will be my take on this question.
Thank you. This next question assumed everyone would be talking about BitVM.
We should define a bit of this here.
It appears that a lot of solutions are revolving around BitVM's development. It's obviously not out yet, but how do you think it's best implemented? Are the trade-offs acceptable? And where do you guys see opportunity for improvement?
You can start.
Okay, that's true. I mean, there aren't right now, in my opinion, many designs around BitVM, bridge designs. I think Robin has his own. I believe Super Testnet has its own design. And right now, Citraea's BitVM bridge design, Clementine, is one of the solid ones out there. We have our blog post laid out how the mechanism work in our design. We have it on GitHub. It's work in progress, and it's still an area to explore, and it's a hard task to do. I don't think there are many teams out there that can pull it off, to be honest, and that's why there are a handful of people, and there are not many designs out there. For our design, I just mentioned about because of ZK proof. So what we do, we aggregate the proofs inscribed on Bitcoin and merge it together. So you have one single success proof, then that's kind of verified in BitVM, right? We also verify with global rules there. Obviously there are trade-offs. We all know, and it's still, I think along the way, some of those trade-offs might be gone. I mean, right now with BitVM2, we can actually, I think, prove it with one transaction. It used to be like 40 transactions. So this really happened in like 5 months or 6 months. It's like there are some really big brains working on this. I think it's going to come a long way. But some flaws will stay. You will need some opcode to fix some of those flaws. But I still believe those flaws are better than overcodized bridge designs. We will see how it's going to work in production, right? And our team is right now in Hacker House working really hard to pull this off. And I'm really kind of, what I'm excited about Citra is that we're trying to kind of be at the front of this, innovation, testing of this, and I'm really excited that we're gonna all see as Bitcoin scaling community how this all works out. And I trust my team. I think it's gonna be awesome.
Yeah, my big layer team actually working very early in the BigVM projects, and we build the largest Chinese community with 50K followers, and we wrote a lot of analysis, and we try to build a community, BigVM community in the East, and we also try to build a community in the West we call BigVM Club. And this is we do something public goods to the community. And second, about BigVM itself, I like to talk several points. First is about actually as a C3 friends meeting I mentioned, each design itself need a lot of improvements. So we sort of something like the operator, the multi-sig operator. So we need more talents to enter this area to join the research, and hopefully I think we'll be very happy to see there are over 5 teams are working on BigVM scheme. That's very good side for it's a very good small phenomenon for us. We like to build the BigVM community and the whole together thing. The BigVM is something like a ZK-EVM in 2021 and 20. There in the next few years or next few months, there may be some alpha, some several versions of BigVM. Yeah, actually we already see several versions of the modification about it, and about the landing and about the implementation on mainnet. Actually, it is about cost. If we can utilize this whole progress, end-to-end whole progress, BigVM progress, whenever to verify the arbitrary computation or the ZK proof process itself, it is the key point is cost. If we cannot make it cheaper than the layer 1, that make nothing sense about to build layer 2. So it's about the cost. And yeah, for me, I liked to work with the community partners and all of the teams building on BigVM projects, including the official team and the C3 team and our teams to work together, because BigVM itself just opened a new door for building a settlement layer on Bitcoin, but it needs more resources and talents to join this campaign and join this game and join this research. Yeah, thank you.
I've been working, Alexei and my co-founder and I, we've been working on Bitcoin bridges since 7 years now. Actually, that's how we kind of met doing that, doing our PhDs on this. And it's really hard to build Bitcoin bridges, and BigM is no different to that. It's super cool that there's almost like a global movement, especially in the Bitcoin space, around it. I do think it's a bit early to kind of talk about very specific trade-offs, because I do think there will be, but there already are different instances of what people call BitVM, right? There's BitVM the concept, and there's BitVM the different kind of implementation approaches. The one aspect I think that wasn't yet, or you touched on it with the cost, right, is kind of usability of these bridges. The core part will be to make it secure by BitVM, but then still ensure that users can actually use this thing and don't. If you need to spend like a few Bitcoin transactions to actually do a fraud proof, and you need to spend, I don't know, hundreds or thousands or tens of thousands of dollars, your average user won't be able to use this kind of thing. So the way we think about it is, there's probably going to be a few different variations of how BitVM will work, and it will need to work in tandem with something else, very likely some sort of peer-to-peer swap, maybe, where you have, say, institutions, miners, people with a lot of Bitcoin who would actually set up the BitVM itself and bridge over Bitcoin to Rollux sidechains, and then have a very easy kind of onboarding experience for your average user, because I don't know how you guys are, but usually when I try out a new sidechain rollup, I don't want to send out half a Bitcoin over there. Probably I want to try it out with like I don't know, $10, $100 or so, and I don't want to spend like $1,000 in transaction fees and that. That just doesn't make sense. So to me, it's like really the trade-offs. Yes, security very important, but UX is a really crucial part of that. And if we as L2 sidechains want to see any traction, like that needs to be a problem that needs to be accounted for in the design space.
It seems like we're talking about Bitcoin bridging through BitVM, because you can use BitVM for all sorts of things. But if you're, I think talking to ZeroSync guys, they were thinking like we're probably going to be using it for bridging first. It doesn't make sense to do much more than that. But looking in the context of bridging, then you get into light client security, right? So if you're using any sort of thing with BitVM related to a bridge, it gets a little bit technical, so bear with me on this. You end up having a light client where if you're doing things right on Bitcoin, your light client is on Bitcoin. You're using a Bitcoin light client, which means that the attack there would be to selfish mine, or on a private fork, you're mining another history of Bitcoin. You're potentially trying to 51% attack Bitcoin for the length of time needed to trick the history of Bitcoin to be able to attack that light client, to be able to take the Bitcoin. So for example, if it's 50 blocks, your system is set up so that you've bridged over from this system into another system that posts everything on Bitcoin. It's 50 blocks. So if you can fake 50 blocks faster than the Bitcoin chain, which means you're 51% attacking Bitcoin, then you can take that, the amount of Bitcoin in the bridge and run games with it, because no one can challenge you. You've attacked that system. That's why we're saying light client security matters. So even if you put everything on Bitcoin, it's still not safe. And these are the Nash equilibriums we're thinking about, like, okay, well, this didn't exist before, but now we're adding these new games to Bitcoin, especially with Opcat. If you do that, then you're going to open up these new attack vectors and new bounties. So in our solution, we thought about that problem, and we thought, okay, can we improve upon that? That's pretty good. Like 51% attacking Bitcoin for 50 or 100 blocks is pretty safe, right? It's going to cost you tens or hundreds of millions of dollars. So if there's less than tens or hundreds of million dollars in the bridge, it's fine. But what if it's just one BitVM bridge with 1,000 operators, and that's the one that everyone starts to use? Well, then it starts to get interesting, right? In our solution, we've analyzed that, and we thought about the Nash equilibriums around there. The Nash equilibrium is you as a person, independent actor in the game, in a cooperative, under a cooperative game theory. What's going to make it more profitable for you to act in this, given everyone else's economic decisions, right? So if everyone is acting a certain way, taking their next step, what is the most profitable for you? And if you can always decide that, like, okay, these guys are acting this way, I'll just take this step and make the money. That is how we have to analyze these variables. And it's not analyzing based on how Bitcoin performed before, because that Nash equilibrium is totally safe. There's selfish mining concerns, but you can't make too much money on that. By trying to reorg Bitcoin, you're just censoring transactions. There's no money to be made doing that. But if there's a bounty, there's a sitting duck, a liquidity pool, then it opens up a different. So in our solution, we thought, okay, merge mining by itself, which is where we started, isn't very secure, because you can repurpose the hash and selfish mine a fork and then steal the Bitcoin. You actually don't lose any Bitcoin revenue either, because you're just repurposing your hash. You're not losing your block reward on Bitcoin, you're just repurposing the hash and fake mining a chain and then doing that to do something, attack the light client by faking the history, right? So what we added was finality on the L2. By adding finality, you can actually attribute fault to the Bitcoin miner, because now if the Bitcoin miner is mining a fake chain, he will be he will have a proof of work slash effectively, right? Bringing sort of the attribution of proof of stake into proof of work. So once you have that solution, then you analyze it under that Nash equilibrium. You end up realizing that you have if the sidechain is 66% security, you have a 66% security of the sidechain plus the selfish mining 51% security of Bitcoin, right? So you don't get the full Bitcoin security like you would be if you're putting stuff on Bitcoin, but you do get a sense of 51% security, like just vanilla merge mining. So to steal from that solution, you would then first have to go attack the sidechain. And that's a detectable event. If you're attacking the sidechain, you're accumulating tokens, you're getting 66% of these tokens, and then you gotta go attack Bitcoin by 51%. The core idea here is the detection, which you can also detect and attack on Bitcoin itself. When the hash rate moves over, you can detect that event. You can't react in that situation. In our solution, you can react. So before the attack happens on Bitcoin, the sidechain's being taken over, you have this buffer of time where people could be like, okay, let me just take my Bitcoin out of the bridge, so I think an attack might happen. Well, if the 51% attack on Bitcoin hasn't happened yet, then people can't, that equilibrium, the profitability starts to drop if you know that people can move their coins. So the detection and reaction is important in analyzing these light client securities. And this is why it's important when you're dealing with sidechains to really think about it. Even if you're going to be using Bitcoin itself, if you're going to make any sort of IOU Bitcoin in your system, then you have to think about this problem and how to solve it effectively.
In a lot of ways, it's amazing. Everything being talked about today is somewhat enabled by BitVM, if not practically, but just how it's made people dream. Given everything said today, what do we need to be building on Bitcoin that we are not currently building or talking about?
I think crypto economic incentives, we probably started talking about that, but I think not enough of it to talk about, because when you have BitVM, you have the operators. I think verifiers being open-ended is great, but the operator list is still static. I think solutions need to come there. The other thing is quantum security. I think is important. I think with OpCat and you are getting a semblance of Lamport signatures, so you could potentially usher in something with quantum security. But the problem there is the hash algorithm might not be safe in the post-quantum world. So I'm trying to think about how in that world would you usher in post-quantum security. I think Vitalik did a post for Ethereum on what would happen. The difference with proof of stake in Ethereum is it requires human social governance to counteract these black swan events. In Bitcoin, there really is no social governance. That's the benefit of having Bitcoin, is no human social governance. But you do have to consider a case where if this happens, what would you do? These are some things that we do have to think about, and it's unrelated to scaling and all that. But for BitVM, definitely, I think crypto economic security is definitely something to patch the holes around whatever problems there are with it.
I think the key things that I would want to see built on Bitcoin are probably applications that the average user can use. If I go to my parents and tell them about Bitcoin, they're like, how does this work? And then teach them about, setting up seed phrase, hardware wallets. It's all very complicated. And if we look at Lightning today, for example, it's like kind of 90% of that is custodial. And in my opinion, that's a problem. And what I would really want to see is, easy to use applications. Maybe you get like a little Bitcoin savings account, but it's actually non-custodial, and you can actually send payments that are reasonably cheap, while still retaining Bitcoin security. And to me, that's the one key thing if we want to move the space forward, is to 100x our UX experience for the average person.
Yeah, actually, a part of to agree with this friend. I always thinking about the mass adoption for Bitcoin or for the crypto. For me, always thinking about the stablecoin transferring, because we actually have a lot of debates on what the layer 2 or some other things. What if we can have a simple, secure, just a stablecoin payment system based on Bitcoin? I think this can reach mass adoption, maybe millions of people or the billions of people. This can benefit a lot of countries that do not have a very good bank account inclusions. Imagine and combining with the existing technology, including complexities, MPC project, MPC TSS, that can enable user to have experience of key phrase list experience, lower the entry barriers for the user, normal users. This is always the application scenarios that I've always thinking about. Yeah, I happy to work with any proposals, any builders have this kind of idea, and I like to work with these guys and to align with the industry investments for big layer projects, which we have worked before in the northeast North America. We like to promote this kind of scenario application scenario here.
I don't think there is much to say, but I definitely agree about the applications part, like kind of going back to basics. I think we need to bring primitive DeFi like narratives on Bitcoin and up and running, like Bitcoin is the best collateral you can have, right? Like you need to have lending and borrowing protocols with good amount of liquidity so that people can actually, with good UX too. I mean, some of the, even currently up and running sidechains, I don't like, how you handle with all of the UX and as a protocol, you have definitely responsibility on that part. And Bitcoin backed stable coins, we should definitely focus on the basics and then start having wild ideas, I guess, later. I think we need to definitely enable those primitives on Bitcoin.
That concludes all the questions. And I want to open the floor for a couple questions if anyone has anything they want to ask. All right, thank you everyone.
Hey guys, we do have another panel coming up in 10 minutes, so we'll take a little break.